So pH of a strong acid. And here I'm referring to acids such as hydrochloric acid, HCl. Of course, it's only the acid when it's dissolved in water. It's actually a small molecule, a gas, but if we dissolve it in water, so excess water, and it becomes HCl, an aqueous solution, and that's when we call it hydrochloric acid. This is just the hydrogen chloride molecule. By definition, strong acids dissociate fully in water. So when we write HCl AQ, we're indicating for a strong acid that it completely dissociates to the hydrogen ion and the chloride ion, and put a little AQ next to those. Whereas a weaker acid, as we'll see shortly, they do not fully dissociate, only partially. Now no doubt you've been told by your teachers that the H+ ion doesn't exist as such in aqueous solution. The charge density will be very high, so what it does is it combines with water. So you've got H plus a H2O molecule forms the oxonium ion, H3O with a plus. So what it's doing, it's forming a dative covalent bond to the water. Here is the water molecule. With its two lone pairs, and the H+ can come along and it can use one of the lone pairs of electrons on the water molecule to form a dative bond. So here we go, we've got so this would be the structure of the oxonium ion. And then so that's no longer a lone pair, it's going to be the bond. And this is the new hydrogen that's come along. So that would be the H3O plus ion. So I'll put a charge on all of that. It's called the oxonium ion. But you'd still write it with an AQ sign. And when you see H+ with a little AQ, that tells you, really does mean the hydroxonium ion. So just to keep things simple, I'm just going to write H+, but for the sake of accuracy, that does mean the hydroxonium ion. Now let's imagine we've got a bottle of hydrochloric acid, and on the label it says 0.2 moles decimeter cubed HCl. So we can write 0.2 moles decimeter cubed on here. Because it's a strong acid, we're assuming complete dissociation. So whatever the concentration of the HCl is, that's the concentration of the H+. So the concentration of the H+ is going to be 0.2 moles dn to the -3, as is the chloride ion, dn to the -3. So if you imagine this marker pen is the molecule of H+, of hydrogen chloride in water, completely dissociates. So for every one of these, you get one of these and you get one of these. So if that's 0.2 moles in a decimeter cubed, you get 0.2 moles of that and 0.2 moles of that. So we just need to take the log of this, and then I think we've just done that one. So if I take log of 0.2 equals 0.7, it's underneath. So on your calculator, just do log of 0.2 and you get minus 0.7, and you just change the sign. pH equals 0.7. Okay, That's for a strong acid.